Okay, and equation of motions, and that one is very straightforward. So simply, we still deal with the 1 degree of freedom systems, and this one I won't put too much time because I assume we have done that one. For this case, the simply we going to do is again here we have we take the free body diagram on the mass on the degrees of freedoms, which is the mass block. And then we put all the forces together to come into using Newton's law. So we take the free body diagram. On the mass block. Okay, so assuming the mass block has moved to right a little bit by that much, so that means by looking at that original system, we have the recovering force from the string, and that will give us its kx. And again, due to the velocity, and we know that has a recovering force from dampers, and that is cx dot. And also, in addition to the chapter 2, we have additional loading, the f of t, and that is our external loading. Okay, f of t can be anything, but in chapter 3, we focus on sinusoidal excitations, and in chapter 4, then that can be anything. Okay. So this one, basically, all the forces are there to provide the inertia, the motions. Okay, so that means this one going to is mx double dot. Okay, so using Newton's law and all the forces and equal to mx double dot, and here we take the sign convention along with our degree of freedoms, so that takes sign convention like this. So that means minus kx minus cx dot plus f of t and equal to mx double dot. Okay, so move the things around, then we would get is mx double dot plus cx dot plus kx equal to f of t. So that is our equation motion. So basically for this case, everything will be 100%, almost 100% the same as we learned in chapter 2, but just one more term you need to consider. Just consider the external loading. Consider that one into your formulation, then put into consideration of the Newton's law, the same as we before. Okay, good. In terms of the homework exercise,